During this video, we are going to show you how to name salts according to UPAC. First of all, what is naming? Naming is a set of rules used to naming organic compounds. There are rules for naming organic compounds, which are the compounds that we are going to see in our next semester, and rules for naming inorganic compounds, which are the compounds that we are going to see during this semester, okay? Inorganic compounds are classified according to their chemical functions in oxides, base, acids, and salts, okay? Who is the organism that defines the rules for naming? This is UPAC, okay? UPAC is the highest authority on chemical nomenclature. UPAC means International Union of Pure and Applied Chemistry. They are the ones that define which are going to be the rules that we are going to be using in all the naming problems, okay? In all the things related with naming, they define which are going to be the rules that we have to follow. Okay, we're gonna start with salts in this video. First of all, we have to know what is a salt. Salt is an ionic compound that results from the neutralization or the combination of an acidic and a basic substance, okay? What are ionic compounds, okay? Ionic compounds are going to be compounds that are formed by a metal and a non-metal. And if we remember of what we saw during the time that we studied the periodic table, the metals are the elements that we have on the left side of our periodic table. Non-metals are the ones that we have on the right side of my periodic table. Ionic compounds are going to be held together by ionic bonds, okay? And because of their strong attraction forces of the ionic bonds, they are going to be typically solid at room temperature, and they are going to have high melting points. Examples of products that are salts will be the sodium chloride, which is a regular salt that we have in our kitchen, sodium sulfide, magnesium chloride, etc. Okay, those are ionic compounds, and now we are going to see how do we name them. Salts can be divided or classified as binary salts and tertiary salts. What's the difference among them? Binary salts are those salts that are composed of a metal and a non-metal, okay? The difference between binary and tertiary will be that in tertiary, we have a third element besides the metal and a non-metal, which is going to be the oxygen, okay? So binary, metal and non-metal. Tertiary, metal, non-metal, and oxygen, okay? The rules for naming binary and tertiary salts are going to be a little different because if we have an oxygen, we will have a polyatomic ion, and we will see in a moment what is this. And we have to change a little bit the way to name it. Binary salts are going to be named as follows. First, we name the metal as it appears in the periodic table. It's very important that we use Roman numbers if we have a transition element, remembering that transition element are the ones that we have in the center or the ones that have multiple charges. We want to review them in a moment. And then we are going to write the first syllable of the non-metal and the ending "ite." Okay, so if we have like the most typical example, NaCl, the name of this compound will be sodium because it's the name of the first element, and then the first syllable of the non-metal and the ending IGE. Okay, that's for binary salts. Every time that I have two elements, okay, and the first element is a metal and the second element is a non-metal, it's a binary salt. And the way to name it is we're going to name the metal and then we name the non-metal, changing the ending to IDE. What about tertiary salts? Tertiary salts are going to be named in this form. First, we name the metal, okay? It's important that if we have a transition element, we have to use Roman numbers, okay, for the oxidation number or the charge that they have. And then we are going to name the ion whose ending is going to be in ite or ate, okay? Remember that you have a list of all the polyatomic ions, so you will take the name depending on the polyatomic ion that you have. For example, here we have NaClO2. Na will be sodium, and then if we search in our table, we will see that ClO2 is chloride. So the name of this compound will be sodium chloride. Chloride because ClO2 is chloride, and sodium because it's the first metal that we have, okay? Let's make the following examples in order to practice, okay? Just here we have the chart of the polyatomic ions, and here we have the periodic table with the different charges that the elements will have, or the oxidation number. Okay, we have the first example. The first example, it says FeSO3. Just by looking to the example, we can see that we have three different elements. We have 1, 2, 3 different elements, okay? Therefore, if we have 3 different elements, this one is iron, which is a metal, okay? Remember, here we have in the periodic table, metals are the ones that we have in light blue, okay? So this is a metal, and SO3, it's a polyatomic ion. If we go back to this chart, we have here SO3, which is, here I'm gonna point it, is sulfite, okay? And it has a negative charge of 2, okay? Let me see if you can see it, is 2 negative, okay? So if we have that SO3 is sulfite, okay, and we have that Fe is a metal, and we have 3 different elements, we can define that this is a tertiary salt, okay, because we have a metal and a polyatomic ion, okay? How do we name tertiary salts? First, we name the metal, in this case will be iron, okay? Since iron is a transition element, we have to write in parentheses a charge. But before writing charges, let's write the name of the polyatomic ion. SO3 is sulfite, okay? What we have missing is going to be the charge that goes in here in parentheses with Roman numbers, okay? So if we go back to this slide, okay, we can see that iron can take 2 charges. It's either +2 or +3. We have to remember always that when we have neutral compounds, meaning that we do not have a charge on them, the sum of the charges must be equal to 0. Okay, so in this case, since we have sulfite, SO3, okay, that has a charge of -2, according to what it says here, here we have the -2, okay, which is a charge that iron must take in order to have balance, a balanced compound. And by balance, it means that the sum of the exponent or the sum of the charges, it's equal to 0. So in this case, we have to say that, let me just erase this, okay? That for this compound, okay, iron must take a charge of 2, has to be 2, okay, in order to balance and to have a compound structure, okay? Why am I saying this? Because if we write Fe with a charge of +2, SO3 with a charge of -2, the sum of our exponents, okay, is going to be 0. Here we have +2, -2, and we have 0. Okay, this is what we have to do when we have transition elements. let's make the next example, okay? In our next example, we have two elements. We have aluminum and we have oxygen, okay? So since we have only two elements, we can say that this is a binary salt, okay? Normally, structures or compounds that have oxygen can be called also oxides, okay? So you can say that this is a binary salt or an oxide because it has oxygen, only when we have oxygen. The way to name binary salts is going to be the name of the element, okay, as it appears in the periodic table, including Roman numbers if we have a transition element, and the name of the nonmetal changing the ending to IDE. Okay, so if we check in the periodic table, aluminum, it's located here, okay, but it's not a transition element, okay? It doesn't have multiple charges, okay? It only has the charge of +3, okay? This +3 that we have. So we do not have to include Roman number in the structure, okay? So the only thing that I'm gonna be writing is aluminum, and the name of the nonmetal changing the ending to IDE. So this will be oxide, okay? Let's make the next one. In our next example, we have lead 2 oxide, okay? By looking to the ending, we can see that it ends in IDE. So it is not a tertiary salt because tertiary salts will end in ite or ate, okay? But if it is hard to see this, let's first write the structure and then define what type it is, okay? So I know that for lead, the symbol is Pb, okay? And for oxygen or oxide, the symbol is O. When we have the name and we have to write the structure, we have to check the charges in order to see if they are balanced or not. What is this? Lead is Pb, okay? In this example has a charge of 2, okay? This is a charge that I have here. And oxygen has a charge of -2. How do I know that it has a charge of -2? If I go to my periodic table, here I can see that oxygen, since it is located in group 6, has a charge of -2. This means that it has 6 electrons in the last level of energy, so it needs 2 electrons in order to complete the octet. So it has a charge of -2. So since we have lead with a charge of +2 and oxygen with a charge of -2, the sum of my exponents is going to be 0, so we leave it like this, okay? We do not have what we call cross charges, okay? We will see in a moment what is this. Since now we have to write the classification, since we have only 2 elements, okay? This is going to be a, has to be with green, a binary salt. Okay, let's go to our next example. It says iron 3 nitride, okay? By looking to the ending is IDE, so it is not ite or ate, so it is not tertiary, it will be binary. But let's look at with the example. Iron, which is the symbol for iron, Fe, okay? Nitride comes from nitrogen, so I have an N. But I have to look to the charges and check if they are balanced, okay? So how do we do it? We write here, iron, for this example, has a charge of +3. The charge is given by the number that I have in parentheses. And then nitrogen. Nitrogen, if I go to my periodic table, I will see that nitrogen has a charge of -3 because it's in group 5, okay? So what I would do is I will write the charge of -3 here. So once again, the sum of my charges is 0. So I leave it as FEN. Okay, since we have 2 elements only, this is a binary salt. Okay, let's look to our next example. We have how many different elements? We have 1, 2, and 3. Okay, so therefore this is a tertiary salt. Okay, tertiary salt. I have to look for the name of the polyatomic ion. I have to search in my chart for NO2. Okay, so I will go to my periodic table. Let me see if we can see it. Yes, it's here. Okay, NO2. Okay, it's located, and I'm gonna point it out with blue. NO2, it's here. I hope you can see it. NO2 is here. Its name is nitrite. Okay, and it has a charge of -1. Okay, this NO2 and the name will help us to write the name of the compound. Okay, so I'm going to erase it so we do not see it. Okay, so the name of this compound will be the name of the element of the metal as it appears in the periodic table. So this will be iron. Okay, since it is a transition element, because I know that iron is here, okay, so it will have Roman numeral. I will have to define which is the charge. I will leave a space with the Roman, with a parenthesis in order to write in a moment the charge, and I will write the name of the polyatomic ion, in this case, nitrite. Okay. I have to define which is the charge that iron must take for this problem. As we said previously, the sum of my charges must be equal to 0. Okay, so I have Fe, NO2, 3. We said previously that NO2 has a charge of -1. This -1, once again, comes from my charge in which I have nitrite, okay, that has a charge of -1. Okay, so what I have to do now is this number 1 is the one that I'm writing here. And since I have to multiply times this 3 in order to get the overall charge of nitrite is -3. So which is the charge that iron must take for this example in order that by the time that I add it, we get a 0. So iron must be +3. Okay, so we can add them and we will have a 0. As a hint, okay, when we have polyatomic ions that have a charge of +1 or -1, the number that we have at the bottom will be equal to the charge, okay? So in this case will be iron 3 nitrite, okay? Let's make another example. Our next example has, it says gold 1 fluoride, okay? I will write the symbol gold, it's AU, okay? And fluoride comes from fluorine, okay? And we know that it has a charge of -1. So I will be writing the symbol, which is F. Since we only have 2 elements, this is a binary salt. We do not have to cross charges or anything because we already have that sum of the charges equal to 0. One of the gold, one of the negative one of the fluorine, we are going to get the 0. Let's look to the next one. We have 2 elements, so we know that it's going to be a binary salt. Okay? The name of the first one is aluminum. I will go a little bit faster. Aluminum. Okay? And S stands for sulfur, so it will be sulfide. Remember, when we are passing from formula to name, the only thing that we have to look is if we have a transition element, we have to include the charge in Roman numbers. Okay, in this case, since aluminum is not a transition element or it doesn't have multiple charges, we do not have to include anything. Okay, let's see the next one. We have calcium carbonate. Since it ends in ate, okay, this is going to be a tertiary salt. Okay, before defining this, we are going to write the symbols. We have calcium is Ca, and I have to look in my chart for carbonate. Okay, let's see carbonate. What is it? Carbonate, here is it. I'm gonna point it out with blue. Carbonate is here. Let me see if you can see it here. Okay, with blue. And it has a charge of -2. This charge will help me to balance the charges by the time that we write a compound. Okay, so if I go back to my example, okay, let me just erase it. The structure will be Ca, and I'm gonna write CO3, O3. And the next thing that I have to look for is the charges, okay? Calcium. Calcium is located in group 2, so it has a charge of +2. Carbonate has a charge of -2, so it's already balanced, okay? So we leave it like that. Since we have 3 different elements, this will be a tertiary salt, okay? The next one, we have 3 different elements, okay? Or we have oxygen in the polyatomic ion. So this will be also a tertiary salt, okay? I have to search in my chart for PO4 in order to know which is the name that it has, okay? PO4, I will point it out with blue. PO4 stands, here you have it, for phosphate. And it has a charge of -3, okay? Remember, phosphate charge -3, okay? So what I will do now is I will go back and I'm gonna write the name of the first element as it appears in the periodic table. In this case is magnesium. I don't think it will fit, okay? And then the name of the polyatomic ion in this case is phosphate. We do not change endings, okay? We just write it as it appears in the chart, okay? And finally, we have sodium bicarbonate, okay? I know that in the name I will have an Na because it's for sodium. Now what I have to look for is what is the symbol for bicarbonate. Okay, bicarbonate, let's see, what is it? If I have it here. Let's see. Okay, here we have bicarbonate, hydrogen carbonate or bicarbonate. Okay, here we have the symbol. and it is HCO3 and it has a charge of -1. Okay, so this is what we are going to use to write the name. So we go back to the example, okay, and we are going to write sodium and the name, which is about the formula, which is HCO3. So it will be HCO3. I'm gonna write it here down so it fits. Okay. Okay, this one goes here. Checking the charges, HCO3 has a charge of -1, sodium has a charge of +1 because it's located in group 1. And since we have 3 elements, this is a tertiary salt. I hope this was clear for you in the naming of binary and tertiary salts.